So today we're going to take a look at a problem on rotating unbalance. We're still in chapter 3. We'll see how can you find solutions or response to a rotating unbalance problem. So when you have a problem, so usually we have to divide it into the given. Look at the variables. What are the variables given? So for example, in this case, if you look at here, you have 50 kilogram as the mass, and then you have 1000 RPM as the speed. You have unbalanced mass, so you have to highlight what is the variable for that unbalanced mass, and a radial distance of 0.1 meter. Okay, so maybe I just highlight some of the important parameters here, and you want to find the following. A is the spring constant of the elastic support that transmits no more than 25% of the unbalanced force to the foundation, and the magnitude of the force transmitted to the foundation. So maybe if you want to write the listed variables. So basically what you have here, you have your mass, just so don't forget in this problem the variables that we use is slightly different, where your mass of the machine we label it as capital M. So capital M, you have 50 kilogram, and then you have your speed, your omega. Okay, so your omega here is in RPM, so you have to convert it into your radian per second. So you have to times 2 pi over 60. So you should get, if you calculate that, you should get 104.72 radian per second. And then you have your 2 kilogram. It's actually the unbalanced mass. So in this case, in this chapter, we define it as small m. So the capital M is the machine mass or the compressor mass in this case, or the hose mass. And then you also have the eccentricity. Okay, so make sure E is in meters. So in this case is 0.1 meter. And you have your zeta is equal to 0.1. There's no unit for that. Okay, 0.1. So in this case, they put a condition where for you have to find the spring constant of the elastic support, okay, which is your K. So what you find is your K at your, if the transmitted force is no more than 25%. So the way you do it is basically here, that means your force, okay, at when your force, okay, I just put it in terms of absolute value so that we know that absolute value, because if you calculate then you would have plus minus value. So 25% means 0.25. So that's how you write the equation. You can also refer to equation 3.84 later on when you solve it. And so basically what we want to find here, we have to find the A, which is the spring constant K under that condition, and B is basically you want to find the magnitude of the force transmitted, or the FT. Okay, let us move on to the solution. So maybe you can refer, since once you look at the problem, you can see that the question addressed the unbalanced mass. So you know that you have to refer to equation 3.84, Okay, or if you look at your notes, okay, if you refer to your textbook, you can refer to equation 3.84, or if you look at your textbook or your the notes, you can also look at under lecture 9. Okay, you can find there are a few equations in a different form that you can use, but the one that you want to use is basically the one that has the force transmitted equation, and you can write in terms of remember we define or simplify your R equals to omega over omega n, so you can use that equation and write it in this form. Okay, so basically look for the transmitted force equation or this form for zeta square over r square divided by 1 minus. Okay, so basically when you can write this equation. Okay, so basically it's from the condition that we have set from the question. So this is the equation. So how do we actually rearrange everything? So basically you have here to the power of half. So that means to remove that, you have to square each side of the equation in order to remove to the square root. To the power of half is it means it's a square root. So if you want to rewrite that, you can also at the same time substitute. So you have 1 plus 0.1 square r square. Okay, so what you want to do here is basically you want to solve for your r. Okay, because you don't have k, so you don't have omega m. You don't have omega n. Yeah, so then so it'll be easier if you first remove the square. So plus 4 times 0. So basically you just have your zeta here. So then 1 over 16. So if you work that out, so basically you have to times so that you will remove all the numerator and the denominator. Okay, so from there you can also rearrange. Okay, after that, so this one I've rearranged. Okay, so we have this expression, the first line expression, and you try to rearrange. So put everything on one side of the equation. So considering the equality sign in this equation, okay, you can actually write it as such as well. You have r to the 4, okay, minus 2.6 r square, because now you already have it in the form of quadratic equation that you can solve for. Okay, so from there using formula, the quadratic formula equation, you can actually solve for your r. Okay, maybe in the final you also, or in test, you have your calculator, so then you would have your answer. So don't forget, this is r to the 4, so you have your answer in terms of r square. So you can plug in your values of a, b and c. Basically, sorry, your a is 1, your b is negative 2, and your c is negative 15 in your calculator. Then you can get your r square value. So don't make a mistake. Although you're using quadratic equation, your power here is to the 4. So when you use your calculator, the answer should be r square. So you get 5.3853 here. So if you actually solve for your r, you get the positive root. Okay, so use a positive root. So based on your positive root, then you have your r is equals to this value, square root of that value. So you get 2.3 3206. So these are, remember, we define our R as omega over omega n. So from there, since you have your omega, so you can actually calculate your omega n. Okay. Okay, so basically, once you get your R just now, then you substitute your omega n. So you have your omega 104.72. So you can divide with your R value just now. So you get your omega n. So once you get your omega n, you know that omega n is equals to square root of k over m. So that's why, because you know your, don't forget you use capital M, yeah, capital M, which is 50 kilogram. So you have your, you can actually solve for your K. Okay, so you have your K over capital M is your 50 is equals to 45.1263. Then you can calculate your K. So if you rearrange from the equation, okay, you have K is equals to 50 times your omega n square. So you have 45.1263 square. So you get 10.1819 times 10 to the 4 Newton per meter. So then we have that answer. So we already have the answer for your K. So now we want to see how we can answer part B. So part B is calculating the FT. So now it will be just rearrange or substitute the values. Okay, so if you look at that equation, okay, part B is just to find the T. So for B, the force transmitted, so we know that using the relationship is 25%, so ME omega square. So this is small m, yeah. So you have all the values. So basically, you have 25 times 2, and you have eccentricity. So this is quite straightforward. You already have your omega in the beginning. So actually this one you can calculate earlier, but it's in part B, so that's why we have it a little bit later here. So basically that's all. So you have answered part A and also part B, yeah. Okay, so you have all the solutions how to solve this problem. Okay, so that's all. We'll take a look at another problem after this.